So this is our last example for 16D where we're solving quadratics that have real coefficients, but sometimes they'll have complex solutions. We're going to do the last problem here with completing the square. So we have to solve m squared minus 2m plus 2 equals 0. First, let's refresh our memories on exactly how we complete the square. If we have a quadratic and it looks something like x squared plus bx, we want to make this into a perfect square. To do this, we can express x squared plus bx as x plus whatever b is over 2 and square it all. This will give me x squared plus bx, but I'll have this extra b squared on 4 when I expand through. So to counteract this, what I have to do to make sure I just have that x squared plus bx and I'm not changing it, I have to minus that b squared over 4 from my perfect square. In saying this, it means that x squared plus bx can be written as x plus b on 2 all squared plus b squared on 4. The same process will apply if we have something like x squared minus bx. We can write this as x, this time the sign is a minus in between our two terms. So x minus b on 2 all squared. But again, when we do this, we're going to have this extra b squared over 4 that we didn't have in the beginning. So that b squared over 4 is positive, so to undo it or remove it, we just minus it. That way again, we can say that x squared minus bx is really the same thing as x minus b over 2 all squared minus whatever my b is, square it on 4. This can come in handy when solving these types of equations. It's also handy for graphing, quadratics, and other things like that. Back to our problem. M squared minus 2m plus 2 equals 0. Let's complete the square with the m squared minus 2m part. This is of the same form as like x squared plus bx. Instead of x's, we have m's, our unknowns, and our b will be 2. We have a minus sign in the middle. We can write this as m minus my b, which was 2 over 2 all squared, but remember I have to subtract b squared over 4, or 2 squared over 4, to make sure I haven't added on anything extra. Okay, if I simplify that, I'll get m minus 1 from the 2 over 2, all squared minus 1, and that's from 2 squared over 4. Again, that's just 1. And you can check by expanding your m minus 1 squared minus 1 and make sure that gives you back m squared minus 2m, which it does. So now I can rewrite my equation. M squared minus 2m, I'm just going to sub in m minus 1 all squared minus 1. Remember, I have the plus 2 hanging off the end, and that all equals 0. From here, we're going to simplify where we can. Remember, with my aim to get m equals some complex number. Minus 1 plus 2, that's just positive 1. I'm going to take that positive 1 to the right-hand side and rearrange. This is nice because I can take the square root of both sides. On the left-hand side, the square root will undo the square, so I'll get m minus 1 equals. And on the right-hand side, remember, it'll be a plus or minus square root of minus 1. We know the square root of negative 1 is I, so we're going to replace that in there. So I'll have m minus 1 equals plus or minus I. Bring the minus 1 to the other side. I'm going to put it in front. So I'll get m equals 1 plus or minus I, just for rearranging. Then I'll have two solutions. M equals 1 plus I or m equals 1 minus I. And again, they're going to be the conjugates of each other. Of course, there are other ways to do this. I'm just showing you one way. You don't have to complete the square. Also, notice there's another way to complete the square here. If we break down at the beginning, m squared minus 2m plus 1, that's the same thing as m squared minus 2m plus 1 plus 1. And we know that m squared minus 2m plus 1 is the same thing as m minus 1 squared. So if you break it down like that, you'll notice that that way might be a little bit quicker, and we're going to end up at the same step here in green. But however you like to complete the square or do this equation is up to you, as long as the answer is correct. So go ahead and try 16D, and remember that it takes courage to become who you really are, but you are definitely going to be someone who is pretty amazing.